Welcome to this tutorial about how to configure data types. This is the first of a line of videos which will show you how to create services for the IIP-Ecosphere platform. This will be the first in a series of 6 basic steps. There will be further videos with information on things like Python services or AI using services, but these 6 steps are the basic 3 Java service application we want to create. First of all, we need to configure data types, and for this we need to determine what we need, which data types we need. Prerequisites for this will be in every slide set, so that you know what you should already have done or know about. As it's the first video, there's nothing you should really know about, but you should have an installed platform with its dependencies, as this is needed to make your life easier. An IDE fit with the extensions needed for the IIP-Ecosphere development. You don't necessarily need the IDE, but it has some nice quality of life changes and it's a bit harder without it. You can have both of these things readily available if you're using the development container, which has an own introduction video separate of all of this. Optional, you could also watch the introduction to code generation before this, as it will refer to the file types you will encounter, at least one of the file types you will encounter. So, introducing the ivml structure. The ivml files can be found in the source test easy part of your impl model. Only the ivml files containing part and the name are needed, as well as technical setup. Potentially this deals with things like the AAS server and the transport protocols that are used. This does not need to be edited, especially if you're just following this for these first steps, and is a bit more advanced. Each of them contain part of the complete definition of an application. All services and all types just import their part files, and platform configuration combines all of these files together at one point, because this is what will actually be executed to generate the code. How do I configure data types? The development container will contain an example ready to be worked with. It's called impl model, and this is also what you could find in our JIT if you want to work outside of the container. Our container will have also example files already in it. For the easy structure, they are supposed to only be a guidance and need to be edited. If you're using the impl model outside of a development container, you probably want to grab one of our examples, take the ivml files from this. For example, the Python example would be a good one, and edit these in the same way, so you also have some kind of template to go off of. So the process will ultimately be superseded by UI, which should make this a lot more easy. What do these single files do? So all we need to care about is defining the data types in the all types part file. Why are we doing this? To transport data from service to service, we need to somehow package this data, and this is done by defining data types in our ivml structure. On the bottom left side, we have some example code for a record type, which is defined by the ivml meta model. We will get a bit more to this later, but not really in depth. It will be at least partially covered in the video about building the application. We see fields. These correspond to data types you want to pass on, in this case 3 numbers of different number types and a string. The corresponding class in data will then be translated into Java and Python with the corresponding members fitting the closest data type if there's no concrete equivalent. For each data point we want to put in, we add a field with a name. It always has the structure of name, some name you want to choose. I recommend using lowercase letters, as capital letters led to some errors in the past. And a ref by, which refers to a concrete data type. So integer type would be an integer, float type, a float. All possible types will be shown later in this slide set, or you can also dig into the meta model and look at the different defined data types in there. The little brackets around the names are used to symbolize that these are placeholders and are supposed to be exchanged with a concrete name or a concrete type. As an example, how we would apply this, so we assume we have some kind of input, that would be 3 numbers, and a string, potentially a product ID or something like this, to reference what kind of object we talk about. And we would have an output of a single number into string. So the 3 numbers are some measurements, and our transformer would then combine them by evaluating them in some way and then pass on the resulting number as well as the string to show a result for this object we're talking about. So in this case, this would be in and output of our transformer service. What data types are supported? So there are multiple numerical data types supported, like integer, short, long, float, double, and byte. There are also string types supported, string type normal, string type base 64, and a byte string type. The last two are more meant for transporting data in this configuration. So as a base 64 encoded string, for example. We have arrays like an integer array, a byte array, or a double array. And we have OPCOA data types like the unsigned integer 16, 32, and 64, as well as the signed integer 16, 32, and 64. And the sbyte type. We have the object type, the datetime type, a boolean type, and an enum type. Those are all the types that are default supported. If this is not enough for you, you can further extend this, but this should be plenty for most applications. What you should take away from this is how to create custom data types and how data is transported between services. Not the concrete transport mechanism, more than how they are packaged. What data types are available by default to us, and that you potentially could expand them, but this is beyond this tutorial series. How you should go on and how you could go on is you firstly should edit services. This would be the next step in the process. You could also look further ahead, like building the application, if you have already knowledge about the other parts, or how to test an application.